Unit 1 Review Sheet, Algebra 2 Essentials. So first problem, according to the rules of operations or order of operations, what is the first step you should complete when evaluating the following expression? So we've got 6 plus 24 divided by 8 plus 10 minus 5. Well, order of operations states that we are going to go from parentheses to exponents to multiplication, division, and then add, subtract. So in this case, the first thing that we would solve here is going to be the division. So it's going to be the 24 divided by 8. Question 2, we're looking to evaluate 3t squared plus 4t minus 8 when t is negative 7. So we're going to plug the t is negative 7 in for each of the t's in the problem. So we've got 3 times negative 7 squared plus 4 times negative 7 minus 8. Once we've done that, we should get that our evaluated answer is 111. Question 3, it says use the table of values. Part A asks, is y a function of x? So in this case, is y the output to x's input? So meaning we're going to test the x values and make sure they're each used once. And so each one of these maps to the same number for the most part, but each one is used once. So since each one is used once, this is a function. The second part of this asks, what is the domain? Well, the domain is our input values. So based on the previous question, it's going to be the x values. So 3, 5, 7, 9, 11, and 13. The next part of this says, what is the range? Well, the range would be your output values. So -1 and -2. Remember, if it's repeated, you only have to list it once. For the next problem, it says, given the function g defined by h of x equals x cubed plus 12, find h of 5 and h of -5. I think this g should actually be an h. I think it's a typo, but we can work with it. So we're trying to plug in 5, so we're going to find h of 5. Well, to do that, we're plugging in 5 for each of the x values. So that means we're going to take 5 to the third power plus 12. And when we do this, we get our total to be 137. Then we do the same thing, but this time with -5. So we've got -5 to the third power plus 12. And in this case, we're going to get a -113. I do recommend putting your values that you're evaluating or plugging in for your variable, put them in parentheses so that way if you plug this into your calculator, you're less likely to get an error or to get an incorrect answer. All right, next problem says solve. We're solving 4 times the quantity x minus 15 equals 6. So to solve this, we've got 4 times x minus 15 equals 6. First step is going to be to distribute the 4 to both items inside. So that's 4x minus, in this case, it's 60 equals 6. We're going to add 60 to the other side. So these cancel. We've got 4x equals 66. We're going to divide by 4, and we're going to get, for this problem, x is going to equal 16.5. Question 6 is done very similarly. We've got 38 equals 12 minus the quantity 8 minus 4x. Keep in mind this subtraction sign here is actually just a -1 that we have to distribute throughout. So we've got 38 on the left equals 12 minus 8, but now -1 times -4 is +4, so plus 4x. We'll combine our like terms here. So +12, -8 is a +4. So we've got 4 plus 4x on the right equals 38. Next step would be to subtract 4. So we've got 34 equals 4x. We're going to divide by 4. And we're going to get x equals 8.5. Next on to problem 7. So we're looking at problem 7, and we've got 2/3 x plus 4/5 equals 7/15. There are a variety of ways to solve this. You could just treat it like any other problem, use your calculator to keep track of your decimals, or you can cancel out your fractions. So let's go ahead and cancel out the fractions. So in order to cancel out the fractions throughout this problem, we have to multiply by some common denominator. Well, luckily, the common denominator in this case is just 15. 3 goes into 15, 5 goes into 15, and 15 goes into 15. So this should help us simplify this problem. So when we multiply 5 by 2/3, we get 10, so we've got 10x. And then 5 times 4/5, well, that's going to give us 12. And then 7/15 times 15 is going to give us just 7. So this is much easier to solve. And so now to solve, we subtract 12. We've got 10x equals -5. We divide by 10, and we're going to get x to equal -1/2, or -0.5. Question 8, we've got a plus 6 over 2 minus 6 equals 114. So we're solving for a. To solve for a, we start by moving the 6, so we add it to the other side. So that's a plus 6 over 2 equals 120. From there, we're going to multiply by 2 on both sides to get rid of the 2 in the denominator. So it's a plus 6 equals 240. And then we just need to subtract 6. And so we get a equals 234. Question 9 is a little hard to see. Sorry that the review is a little blurry, but it's y over 8 plus 2 equals 5. To start this problem, we're solving for y, so the first thing we're going to do is actually move the 2. So we're going to subtract 2. So we've got y over 8 equals 3. Then to get rid of the division by 8, we multiply both sides by 8. And in this case, we get y to equal 24. Question 10, we've got 5x minus x minus 1 equals 13. The first thing we have to remember is that this minus outside is really a -1, so we're going to distribute it. So that's 5x minus x plus 1 equals 13. We're going to combine like terms here, so we've got 4x plus 1 equals 13. From here, we'll subtract 1. We've got 4x equals 12. So 4x equals 12 is where we're at. To get rid of the 4, we divide by 4. And we get x equals 3. Question 11, we need to simplify in the beginning on both sides of the equation. So we're going to distribute the 2 to both items on the left. So that gives us 6x minus 12. Then on the right, we're going to distribute the 3, so that gives us 6x minus 12. At this point, we should see that they're identical problems. Both sides are identical, so we call this an identity. Or we can say infinitely many solutions. Question 12, we've got 10x minus 5 plus 3x equals 8 minus x. First thing we're going to do on the left is we're going to combine like terms. So 10x and 3x gives us 13x minus 5 equals 8 minus x. Let's bring the 1x over, so we'll add 1x to both sides. So that gives us 14x minus 5 equals 8. The next step is to move the 5, so we'll add 5 to the other side. So we've got 14x equals 13. We'll divide by 14. And we get x equals 13/14, or I think it's right around 0.9. 0.9 and some change. Question 13 starts our absolute value problems. And remember, the goal for absolute value is to isolate the absolute value bars before you break it apart and try to solve. So for 13, the goal is to get the absolute value piece by itself. So in order to do that, I'll start by adding 5 to the other side. So we've got the absolute value of x equals 8. And now that I have the absolute value isolated, I can break this apart. I'll get x equals positive 8 and x equals negative 8. Since there's nothing else for me to do, these are my answers. In question 14, we've got the absolute value of x, or 8 minus x equals 8. Since it's already isolated, we can go ahead and separate it. So we've got 8 minus x equals a positive 8, and then we've got 8 minus x equals negative 8. So now we just want to solve. So we'll subtract 8 from both sides and all of the problems. For 15, remember the goal for absolute value is to isolate your absolute value bars. So in this case, we're going to have to isolate it. So in order to do that, we've got to get rid of the negative 2. Got to get rid of the negative 2 by dividing. And when we do that, this cancels with this. We've got the absolute value of x minus 5 equals negative 6. Before we try to break this apart, we should recognize that it's already set equal to a negative. So we actually stop right here, and we're going to write no solution. In order for us to break it apart, we need to have a positive value on the right. Question 16. All right, we're back to another absolute value. So we have to get the absolute value bars by themselves. So we'll start by moving the 4. So we'll subtract 4 from both sides. So we've got 5, absolute value of x equals 5. To get rid of the 5 out in front, we divide by 5. And so we have the absolute value of x equals 1. And now that we have it isolated, we can break it apart. So x equals positive 1 and x equals negative 1. And those are our two answers because there's nothing left to do. Question 17 asked us to solve the formula for m. So if we start with E equals mc squared, the first thing we're going to do to solve for m is to get rid of the c squared. And in order to do that, we undo multiplication by dividing. So that means E divided by c squared equals m, and that's our answer. For question 18, they asked us to solve for a, so we're going to get everything away from the a. So to do that, we'll go ahead and move the b squared first, and we do that by adding it to the other side. So now we've got a squared equals c squared plus b squared. But we want just the variable a, not a squared, so we have to square root both sides to undo the squaring. So the square rooting cancels out here, so you've got a equals the square root of c squared plus b squared. And this becomes your answer. Question 19, they're asked us to solve px plus q equals r for x. So we've got to get x by itself. So to do that, we start by moving q. So we subtract q from both sides. So we end up with px equals r minus q. Then to get x by itself, you'll then divide by p. And so we've got x equals r minus q divided by p. And that's your answer. Question 20, we're solving for x. So to solve for x, the first thing we have to remember is we've got to get rid of that 5 in the denominator in order to get x by itself. So we start by multiplying both sides by 5. So the 5's cancel. We get x plus 3 equals 5z. Then we'll get rid of the 3, so we subtract it. And so we end up with x equals 5z minus 3. All right, so word problems. Connie worked more than twice as many hours as Gary. How many hours did each work if together they worked 48 hours? So, Connie worked 3 more than twice as many hours as Gary. Let's assume Gary worked X hours. And we know they worked a total of 48 hours. All right, so that means Gary plus the combination of what Connie worked. Well, she worked 3 more than twice as many as Gary. So that's 2x plus 3. So 3 more than twice as many as Gary. And when you put the two individuals together, they should add up to 48 total hours. So now we just want to solve this. So we're going to combine our like terms. So 3x plus 3 equals 48. We'll subtract 3. So that's 3x equals 45. We'll divide by 3, and we get x to be 15. So that means, in this case, Gary worked 15 hours, which means Connie must have worked the other 33 hours. Michael and Kevin are running. Kevin gets a 3-mile head start and runs at a rate of 5.5 miles per hour. Michael runs at a rate of 7 miles per hour. At what point will how long will it take for Michael to catch up to Kevin? So we know in this case, Kevin has a 3-mile head start, plus he's going at a rate of 5.5 miles per hour, where Kevin is only traveling at 7 miles per hour. So we've got the equation 3 plus 5.5h equals 7h. We just want to solve this for h to figure out how many hours it's going to take for them to basically be even or catch up. So the first thing we do is we subtract 5.5h from both sides. So we got 3 equals 1.5h. We'll divide by 1.5. And we get that it's going to take right around 2 hours for Michael to catch up to Kevin. Okay. Last question. A Shoppers Discount Club charges a monthly fee of $25 and sells gasoline for $2.15 per gallon. The gas station across the street sells gasoline for $2.55 per gallon and charges no additional fee. How many gallons of gasoline would you have to buy in a month to spend the same amount at either store? So the Shoppers Discount Club, we've got a $25 fee plus the $2.15 per gallon. And we want to know when that's going to be equal to the $2.55 per gallon that the gas station across the street charges. So in order to solve this, we're going to solve for G. So we start by subtracting 2.15 G from both sides. So we've got 25 equals 0.4 G. Then we're going to divide by 0.4. And we get that there should be, after all of this, it's going to take 62.5 gallons for the prices to be the same.